Good morning, my lovely kiddos and my future mathematicians. Today we are starting my favorite chapter. We're starting chapter 9. And in 9.1a, we are going to start off this awesome chapter by talking about square roots. All right, so let's define this first. A square root is an expression. Remember, that's an equation just without an equal sign, written with a radical or root symbol, which I will draw in just a second here. And just a side note that these undo exponents. All right, so here is what a radical or a root symbol looks like. It looks like a check mark with a flat top here. If there is no little tiny number outside of the front, we know that it is unwritten 2. All right, we can have a cubed root where there's a 3 out front, a 4th root where there's a 4 out front, a 5th root where there's a 5 out front, a 982nd root where there's a 902 out front. I think that's what I said. And so, but if there is nothing, then we're going to assume that it's a 2. Okay, so that is what a radical looks like. We have numbers outside of those, and then they also undo exponents. Remember that exponents are these little numbers that go above numbers or variables. If we had a square root outside of an x squared, remember that since there's no number, it's an unwritten 2. The square root and the exponent cancel out, and it would just leave us with that x. All right. Our next definition here is a radicand. And a radicand is the number or expression inside the radical symbol. All right, so if we have the square root of 47, then this 47 would be the radicand in this example. Next, we have prime numbers. Now, prime numbers are numbers whose factors are only the number 1 and itself. All right, so some common prime numbers that we will encounter a lot here are going to be 2, 3, 5, 7, 11, 13, and 17. Okay, these numbers, nothing multiplies to 2 except for 2 and itself, or to 3, or to 5, 7, 11, 13, and 17. Nothing multiplies to these numbers except 1 and itself. Okay, so these are prime numbers. And the last definition should sound a little familiar here. It is coefficient. Now, a coefficient in this context is the number being multiplied in front of the root. All right, so just an example here. If we have a 2 outside of a square root of 5, then this 2 would be our coefficient here. And we're going to read this just like we do normal reading, left to right. We're going to read it 2 root 5. All right, so there are 2 ways that we are going to solve our square roots here. The first way is when the directions say to round. When the directions say to round, then I want you to simply just plug the number into a calculator. Okay? I only want it to the nearest tenths. That is only 1 decimal. Okay? So 10.2, 9.7, 8.3, just 1 decimal. Okay, the second way is if the directions say to simplify. Simplify. Okay, in this case, we have to form a factor tree, which we're going to do an example of in just a second here. We're going to make our factor trees. Okay, in this case, there will be no decimals. If I see a decimal, then I know that you guys are using calculators, not the factor trees, and I have to take off points for that, and I don't want to. So let's make sure that when our directions say to simplify, we are doing our factor trees. Okay, so let's go ahead and do a couple examples here. The first one is the square root of 900. Okay, so since there is no tiny little number out here, we can imply that it is a 2. Okay, so we're going to be looking for pairs, and that's going to make sense in just a second here. So we are going to form little branches, and we're going to think, what is any 2 numbers that multiply to 900? Any 2 numbers that multiply to 900. So I'm thinking 450 and 2. Now 2 is a prime number. Nothing can go into 2 except 2 and 1. So this is the end of this side of our branch. So we continue with this 450. What are any 2 numbers that multiply to 450? I'm thinking 45 and 10. And like I said, these are not the only right answers. Okay? Now 10 splits up into 2 and 5, which are both prime numbers, so those are the stops to those branches. And then 45 goes into 5 and 9. 5 is a prime number, so that stops there. And 9 goes into 3 and 3, which are both prime numbers. Okay? So since we have that unwritten 2, we're looking for pairs of prime numbers, okay? We're looking for just 2 of each. Okay, I see that we have 2 2s. So a 2 gets to come out of the radical. I see that we have 2 3s. So a 3 gets to come out of the radical. And finally, I see we have 2 5s. Again, we're just looking at those prime numbers, the ends of our branches. So a 5 gets to come out of the radical. We don't have any other prime numbers or ends to our branches, so we're done here. We multiply all the numbers that we can pull out here. 2 times 3 times 5, that gives us 30. So in this case, we got rid of the radical completely, and that's totally fine. All right? So the square root of 900 is 30. Let's take a look at a second one here. So we have the square root of 75. Okay, again, since there's no little number outside of that, we can imply that it is a 2. 2, excuse me. Okay, so we're thinking of any 2 numbers that multiply to 75. My first instinct is 25 and 3. All right? So 3 is a prime number. That is the end of this branch. Okay, and then 25 can be further broken down into 5 and 5, which are both prime numbers. Those are the ends of that branch. All right, so again, since we have the unwritten 2, we are going to look for pairs. I see that we have a pair of 5s at the ends of our branches. So that 5 gets to come out of the radical. Now we have a 3 left over at the end of a branch, but we don't have any pairs for that 3. So what happens to the 3? Well, the 3 just gets to keep living inside the radical. Okay, so if we have any leftover numbers, they get to live inside the radical. Number 3, what happens when we have a coefficient already on the outside. Okay, so let's figure that out. We're going to ignore it for a little bit. Let's just do our factor tree. So two numbers that go into 45, I know are 9 and 5. 5 is a prime number, so that's the end of our branch. And then 9 can go into 3 and 3, which are also just prime numbers, so those are the ends of those branches. Since there's no specified little number, we're still looking for a pair, just 2 of each. So we have 3 and 3, so 3 gets to come outside of the radical. And that 5, it does not have a pair, so it gets to live inside the radical. Okay, so this is where this 5 came from. Now we still have this 5 as a coefficient. So what we're going to do is we are going to multiply it by the coefficient that we could that we could have pulled out, that 3 times 5. So 3 times 5 gives us 15, root 5. And I know that we're dealing with two 5s here, but make sure you know which 5 is going where. The coefficient 5 is being multiplied by the coefficient 3 that we pulled out. And the factor 5, that prime number, that is living inside the radical still. Okay, so make sure you know which numbers are going where. All right, sometimes we're going to have to multiply our radicals. So in this case, we have root 11 times root 6. Multiplying radicals is super easy. For 1, we keep the radical. We don't want to get rid of that. And then we just multiply like normal numbers. 11 times 6 gives us 66. And we try to make a factor tree. So 66, two numbers that multiply to 66, what a surprise, are 11 and 6. 11 is a prime number, and 6 goes into 2 and 3, which are both prime numbers. And we don't have a match for any of these. So our simplest form is still root 66. All right? And what happens if we have to multiply where we have coefficients? So here we have 2 root 5 to the second power here. So what that's really saying is that we're multiplying 2 root 5 times 2 root 5. First, we multiply the coefficients. 2 times 2 gives us 4. And then inside the radicals, 5 times 5 gives us 25. Forming a factor tree. This splits up here. So 25 just gives us 5 times 5, which are both prime numbers. And since we don't have a number out here, it's an unwritten 2. We have this match, 5 and 5, so that gets to come outside of the radical. And we have to multiply it by its already existing coefficient of 4. 4 times 5 gives us 20. So the square root of 2 root 5 squared is 20.